I am Rosemary B. Santos from Pasay City East High School, and I will be your teacher for today. At the end of this lesson, you should be able to illustrate permutation of object using tree diagram and listing method. Our topic for today is illustrating permutation of objects using tree diagram and listing method. Do you have any idea about this? If none, don't worry. I'm here to guide you on the process. Let's start our discussion. Let's try to discover. President Rodrigo Roa Duterte, or PRRD, is planning to visit 3 cities: Manila, Cebu, and Davao. In how many ways can he arrange his schedule of visits? If there is no restriction in order of visits, then PRRD may start in any of the cities. After the first city is chosen, he may choose from the remaining 2 cities as his second stop. The remaining city will be his last stop. To solve this problem, we need to find the possible arrangements of the visit schedules. The process of finding the number of possible ordered arrangements of the set of objects is called permutation. But what is permutation? Permutation of the set of objects is an ordered arrangement of the items. If there are n choices for the first stop, n-1 for the second, n-2 for the third, and so on. For the n selection, there's only one choice. One way of finding his arrangement is using tree diagram. Tree diagram is a diagram that shows all possible outcomes of an event. Another way is the listing method. Listing method is a method to list all the elements in the set, separating each element by a comma and enclosing the whole set with a curly brace. Let's solve the first problem. The tree diagram below shows the possible visit schedules. Let us take a look at the possible visit schedules. From the start, there are 3 choices for his first stop: Manila, Cebu, and Davao. If one is chosen in the first stop, then there are 2 cities remaining for the second stop, and finally, 1 city left for the third stop. These are the possible outcomes that we can come up. Manila, Cebu, Davao, Manila, Davao, Cebu, Cebu, Manila, Davao, Cebu, Davao, Manila, Davao, Manila, Cebu, and Davao, Cebu, Manila. Based on our diagram, there are 6 possible visit schedules. Aside from the tree diagram, the possible visit schedules can also be found using listing method. Let's do the listing method. Let's represent M for Manila, C for Cebu, and D for Davao. Listing the possible outcomes, we will have MCD, MDC, CMD, CDM, DMC, and DCM. Counting the list, we will have 6 possible visit schedules. Let us have another example. Consider the set of letters ACT. How many ways are there to arrange these letters using tree diagram and listing method? Using tree diagram, the illustration would look like this. For instance, the first letter can be A, C, or T. If A is chosen, only C and T will be available for the second letter. If C is chosen for the second letter, then T will be the third and last letter. So, the possible outcomes are ACT, ATC, CTA, CAT, TAC, and TCA. Counting the outcomes, we will have 6 possible arrangements. Using listing method, we will have the following arrangements. The set containing ACT, ATC, CAT, CTA, TAC, and TCA. Similar to the result in our tree diagram, we will also have 6 possible arrangements. Let's look at this example. You are making codes using primary colors, red R, yellow Y, and B blue. How many possible ways can you make a code using only 2 colors? Using the tree diagram, let's have this illustration. For example, the first color can be R, Y, or B. If R is chosen, only Y and blue will be available for the second color. So, the possible outcomes are RY, RB, YB, YR, BR, and BY. Take note that since these are codes, RY is different from YR. Counting the outcomes, therefore, there are 6 possible outcomes. This time, let's try the listing method. Writing all the elements of our set, we will have RY, RB, YB, YR, BR, and BY. Can you count how many elements are there in the set? Correct. There are 6 possible arrangements. Very good. Let us have one more example. Suppose you want to find the number of arrangements of the letters in the word read. R-E-A-D. How many arrangements are possible if you will only use 2 letters? The first letter can any of the letters from R, E, A, and D. If R is chosen, then E, A, and D are available letters for the second letter. Using the tree diagram, arranging the letters of the word R-E-A-D, and using 2 letters, we will only have 12 possible outcomes. Comparing with the listing method, listing all the possible arrangements, we will have R-E, R-A, R-D, E-A, E-D, E-R, A-D, A-R, A-E, D-R, D-E, and D-A. Can you count how many sets of elements do we have there? That's correct. There are 12 possible arrangements. Remember, the permutation of the set of objects is an ordered arrangement of the items. Tree diagram is a diagram that shows all the possible outcomes of an event. And listing method is a method to list all the elements in the set, separating each element by the comma and enclosing the whole set with the curly rings. And that ends our lesson for today. Did you understand it very well? If not, you may go back to the lesson presented in your module. If today's lesson is very clear to you, congratulations! You may answer the exercises in our module. Good luck and happy learning!